Welcome to the deep dive. Today we're looking into some fascinating research about making large language models better at tackling complex medical questions.
That's right. We're digging into a paper called ReasonMed, a 370K multi-agent generated data set for advancing medical reasoning. It introduces a pretty substantial new data set.
So our mission for this deep dive is really to unpack what this ReasonMed dataset is, how they actually built it using this multi-agent approach they talk about.
And what it all tells us about maybe better ways to train these models for medical reasoning specifically.
And this matters to you, the listener, because medical knowledge is, well, it's complicated and it changes fast. Getting AI to be reliable here is a huge challenge.
Yeah, and this research offers a specific, interesting approach to that problem. It's definitely worth understanding.
Okay, so let's set the stage, the challenge. LLMs are great at some things, like coding, math, maybe. But medicine seems different. Why is it so tough for them?
Well, there are a few core reasons. Medicine is just incredibly knowledge intensive. You need a vast amount of accurate, high-quality information.
It's not just facts, but applying them correctly.
Exactly, applying them in context.
Yeah.
And then there's the data problem for training. The paper points out that existing medical reasoning data sets, they're often kind of small.
Limited in size.
Yeah, and maybe more importantly, often generated from just one model.
Right.
That can really restrict the range of medical knowledge or even the reasoning styles the training data covers.
Like getting only one perspective on how to solve a medical problem.
Sort of, yeah. And this ties into a bigger question they raise.
Hmm.
What is the best way to train these models for medical Q&A? Should we teach them to output, detailed step-by-step thinking, the chain of thought or Kaneki approach?
Or is it better to train them just to give a concise summary answer?
Right. Is it the process or the final answer that's more important for training? It's an open question.
Okay, so that's the challenge. And ReasonMed is presented as the response.
That's the idea. It's designed to tackle these issues directly.
So how is it different? What makes ReasonMed stand out?
Well, first, scale. It's positioned as the largest open-source medical reasoning dataset available right now.
Largest. How big are we talking?
It contains 370,000 high-quality examples. The paper specifically mentions this is an order of magnitude larger than some previous key datasets.
An order of magnitude. That's a really significant jump.
It is, and these 370,000 examples weren't just generated randomly. They were distilled down from a much, much larger initial set, something like 1.7 million raw reasoning paths.
Wow, so they started huge and then refined it. Where did all those initial paths come from?
This gets to the core methodology, the multi-agent part. They actually sampled answers and the reasoning behind those answers from multiple different competitive LLMs.
Ah, so not just one model's view, but several AI perspectives.
Correct. The goal was to capture diverse medical insights and maybe different ways of reasoning that these various models might have.
That makes sense for covering more ground.
And another crucial point about the final ReasonMed dataset. Each example includes both the detailed multi-step COTE reasoning and a concise summary answer derived from that reasoning.
So you get the show your work part and the final answer in one package.
Yeah, giving researchers the flexibility to experiment with which format, or maybe a combination, works best for training.
Okay, this multi-agent system sounds key. Let's walk through how they actually built ReasonMed. It wasn't just generating data, right? It was refined.
Absolutely. It was a multi-stage process. It started with gathering the questions, about 195,000 of them.
Where did the questions come from?
They sourced them from established medical benchmarks, things like MedQA, MMLU, PubMedQA, MedBinCQA. These are common tests, often based on medical exams or scientific papers.
Using standard, recognized questions as the foundation. Good start.
Definitely grounds it in reality. Then, they used 3 different LLMs as the agents. One was known for medical expertise. The others were strong general models.
Okay, the agents generate the initial answers.
Right. Using different settings, they generated that huge pool around 1.75 million potential reasoning paths for the questions.
That's the raw material. But raw isn't always good, especially in medicine. What about quality control?
Exactly. This is where the really rigorous part comes in. They built a whole pipeline to validate these paths. They checked for answer correctness, logical coherence, metafactuality.
How did they check all that? Manually?
No, they used another AI tool. They call it a verifier. And this verifier was interesting because it didn't just say right or wrong. If a reasoning path was flawed, it tried to identify why, the specific reason for the error.
Ah, so getting feedback on the errors themselves, that seems useful.
Very useful for the later steps. Based on how many agents got a question right, they categorized the questions: easy, medium, or difficult.
How do they define those?
Easy meant 5 or more agents produced a correct reasoning path. Medium was 2 to 4 correct paths. And difficult was fewer than 2. Basically, using AI consensus to gauge question difficulty.
Okay, makes sense. And then they handled each difficulty level differently.
Yes, 3 distinct pipelines. For the easy questions, where there was good consensus, a quality ranker AI simply selected the top 2 highest quality correct paths, mostly selection.
Straightforward for the easy ones. What about medium?
For medium questions, where some agents were right but maybe others made mistakes, they still used the quality ranker to pick good candidates. But then an error finder tool kicked in.
Error definer.
Yeah. Guided by those error logs from the verifier, this tool actually tried to optimize and correct the specific errors in the selected paths, so active fixing.
Trying to improve the reasoning, not just pick the best of a potentially flawed bunch.
Right, leveraging that feedback. And for the difficult questions, where most agents struggled, they didn't try to refine the bad path.
What did they do then?
They used a powerful model, GPT-4 Mini in this case, to generate entirely new reasoning paths from scratch, following a very structured step-by-step process outlined in the paper, restating the question, evaluating options, eliminating choices, and so on.
A complete regeneration for the really tough ones. That's quite an elaborate system.
It is. You have the generators, the verifier, the difficulty sorter, the ranker, the refiner, a summarizer to create the concise answers from the COTEs, and even a final quality scorer.
And did they find that using multiple initial agents actually helped with diversity?
They did mention observing that the different LLM agents seem to have strengths in different medical knowledge areas, which kind of validates the whole multi-agent idea.
So this whole pipeline, generating, verifying, categorizing, refining, summarizing, that's how they got the final 370K dataset.
That's the process. And they report that evaluations using their AI quality scorer showed ReasonMed scoring higher on quality metrics compared to other similar datasets.
Okay, so they built this big high-quality dataset with both the detailed reasoning and the summaries. How did they actually use it then? What training strategies did they test?
Right. This was a key part of the research. They created 3 different versions of the training data from ReasonMed.
Based on the reasoning detail.
Exactly. First, what they call the Cudness instance, using the full detailed chain of thought reasoning path.
Okay, the long explanation.
Second, the response instance, using only that concise summary answer.
Just the short answer.
And third, the reason instance, which was a hybrid, combining both the detailed CUT-T and the summary in the training example.
Ah, the combo approach. So they trained models on each of these.
Yes. They took an open source model, Qwen 2.57b, and fine-tuned 3 separate versions. CutMed 7b, trained on SEDA-T, ResponseMed 7b, trained on summaries, and ReasonMed 7b, trained on the hybrid reason data.
And then tested them on medical questions.
Yep, they evaluated them thoroughly using those standard medical QA benchmarks, again, MedQA, MedMCQA, PubMedQA, MMLU Medical.
So what happened? Which training strategy worked best?
The results were quite revealing. ReasonMed 7b, the one trained on the hybrid data, achieved the highest overall accuracy across all the benchmarks. It hit 69.6% total accuracy.
Oh, so the hybrid approach came out on top.
Right.
Interesting.
It did. CotMed 7b, trained just on the detailed steps, also performed well, clearly better than the baseline models without this specialized training.
And the summary-only model.
ResponseMed 7b, trained only on summaries, was competitive. And importantly, it showed a big efficiency advantage. It generated way fewer tokens per answer, like around 225 compared to over 550 for the others.
So maybe a trade-off there. Good performance, but much more efficient if you only need the summary.
That seems to be the implication. They also noted that training longer, for 3 epochs instead of just 1, generally boosted performance for all models.
More training helped.
Yes, and interestingly, ReasonMed 7b seemed to benefit the most from the extra training, pulling further ahead of CotMed 7b. Maybe the model learned better how to connect the reasoning and summary with more exposure.
And how did ReasonMed 7b stack up against other models out there?
It did remarkably well for its size. The paper highlights that ReasonMed 7b outperformed the previous best models, under 10 billion parameters, by about 4.17% overall.
That's a solid improvement.
And even more striking, on one specific benchmark, PubMedQA, this 7D parameter ReasonMed model actually scored 4.6% higher than LMMA 3.17UB, a much, much larger model.
Wow, a 7b model beating a 70b model on a medical task. That really speaks to the quality of the training data and method, doesn't it?
It really does. It suggests that high-quality, carefully structured data, like this hybrid COTE plus summary approach, can make a huge difference, potentially allowing smaller models to punch well above their weight in specialized domains like medicine.
Okay, the results sound impressive, but like all research, there must be limitations, right? What did the paper acknowledge?
Yes, they were upfront about a couple of key limitations. One was computational resources. Their fine-tuning experiments were limited to models up to the 7B parameter scale.
Like the Quen 2.57b they use.
Right. So while ReasonMed 7B did great, they can't definitively say from this study if the same benefits or training strategies would scale up effectively to much larger models, 70B or even bigger.
So proving it works at larger scales is still an open question. What else?
The other main point was their reliance on other powerful LLMs like Quen 2.572b and GPT-4o models for critical steps in the dataset creation pipeline.
You mean for the verification, ranking, refining parts?
Exactly. Using AI to judge AI. While these are very capable models, the researchers acknowledge they might have their own inherent biases or limitations.
So there's a potential for those biases to subtly influence the final dataset or the evaluations?
It's a possibility they acknowledge. It's hard to have a completely objective oracle when you're using other AI tools in the loop.
All right, let's wrap this up. To summarize our deep dive today, the core focus was ReasonMed. It's a new, large, open-source dataset with 370,000 examples aimed at improving medical reasoning in LLMs.
And it was built using a pretty sophisticated multi-agent system. Multiple AIs generated initial ideas, then others verified, ranked, refined, and summarized them, handling questions differently based on difficulty.
A key feature is that each example contains both the detailed step-by-step reasoning, the get a T, and a concise summary answer.
Right. And when they used this data to train models, they found that a hybrid approach, training on both the reasoning and the summary, worked best overall.
Leading to their ReasonMed 7B model, setting some new performance benchmarks for models of its size on medical Q&A tasks, even outperforming a much larger model on one benchmark.
It really highlights the impact of dataset scale, quality, and maybe this specific hybrid training format for tackling complex medical knowledge.
So here's a final thought for you, our listener, to consider. This whole process behind ReasonMed using multiple AI perspectives for generation, rigorous AI-driven quality control, and representing knowledge in different ways, detailed versus summary, it proved really effective for medicine. Think about where else this kind of structured, multifaceted AI approach might be useful. What other complex domains could benefit from combining diverse AI generation with critical evaluation and flexible knowledge representation? It's an interesting strategy to ponder beyond just medical AI.